Okay, today we are going to discuss the Wilcoxen signed ranked test of matched pairs. And I have an example that came from my stat lab that my current class is using. And what we have here is below are actual high temperatures, and the high temperatures forecast 1 day in advance. And we're using a 0.10 significance level to test the claim that the population of differences has a median of 0. And what do the results suggest about the accuracy of the prediction? So basically what we have here is we do have matched. It's matched because it's 1 day and then the next day. So I am going to first state my hypothesis, which is very important. So my null hypothesis would be the median of the differences equal 0. And this is indeed the claim. I like to signify what that is as well. And so the alternate is the median of the differences is not equal to 0. And it should be no surprise that the equal is in the null and the not equal is in the alternate. So what we have to do when we have a Wilcoxen signed rank is first we have to find the differences. So what I'm going to do is I'm going to extend this table. It's not going to be perfect. Oh, that's pretty bad. Okay, hang on 1 second. So what I want to do is I do want to extend the table so that I can put the differences of these below. So if I look at differences, okay, basically I'm taking the actual temperature minus the high temperature 1 day before. So I literally am just subtracting. So I have -1, I have 3, I have 0, 0, 3, -1, -3, and -1. So all of these values, and I am going to put parentheses since I didn't carry the lines down because I was having trouble with that. These are the differences that we're supposed to look at. And at this point, we rank, but you only rank the values where there is a difference that is not 0. So as you can see, that would be these two values right here in the center are not going to be part of our ranking. We're just going to rank the 1s and the 3s. Now, what's interesting here is that we really have to pay attention to what's going on. So if they share the same distance from the middle, then they are going to have the same rank. So if I do my first 3 ranks, so that, and I look at the ranks without the sign, so those are my 3 -1s, correct? So what I want to do is I literally want to realize that these 3 values are going to take rank 1, rank 2, and rank 3, and I'm going to find the median of these, which is 2. So that means everywhere I have a 1 or a -1, I will have a rank of 2. 2, 2, and 2. So that is where those values come from. So now rank 1, rank 2, and rank 3 are all done. Now I have 3 more values that are the same. So those are going to go in rank 4, rank 5, and rank 6. Again, I'm going to divide by 3, and I'm going to get 5. So all of these have a rank of 5. Now I have to put signs on my rank. So that's part of why it's called the rank sign. So sign rank. So since the difference of the first value is negative, the rank becomes negative. So I have -2, +5, +5, -2, -5, and -2. So that is the signs that go along with that. And this is all important because what we have to do is we have to see the sum of the positive ranks and the sum of the negative ranks in order to find our test statistic. So if I look at that, I'm going to do the sum of the positive ranks. So all that really means is I look at, well, which ones are positive? I just have a 5 + 5. So the sum of the positives is 10. The sum of the negative ranks is going to be the other values. Now, I just need the sum without it being attached to a sign. So I'm basically doing the absolute value. So I have -2 plus -2 plus -5 plus -2. And I end up getting 11. Remember, it's absolute value. So although it's -11, it becomes 11. So this helps us to be able to find the test statistic. So our test statistic is the smaller of the two sums. So the two sums are 10 and 11. So my test statistic equals 10. Now, in order to find the critical value, which helps us to make a decision, I need to find n. Now, normally you would look at, oh, well, I have all of these matched pairs. I have 8 matched pairs. So I'm going to say n is 8. But you only count those that have a difference, that actually have a difference that's not 0. So our n becomes 6. So to find the critical value, we're going to use the table that we have that's prompted for you, or you can find in the back of a textbook. And we use the chart because our differences are less than 30. When the differences are less than 30, then the critical value can be used finding the chart. And I know my alpha level was given a 0.10. So when I use this alpha level and this sample size, I end up getting a critical value of 2. Now, to make a decision using the Wilcoxen signed rank test, I compare the test statistic to the critical value. Okay, so my test statistic is 10, my critical value is 2. So the test statistic is greater than the critical value. So since the test statistic is greater than the critical value, it is not in the rejection region, so I failed to reject the null hypothesis. Which, for our purposes, if you go back and you look at the null and the alternate hypothesis, then we see that that means that we are indeed supporting the claim that is made by the researcher. I hope this helps with the Wilcoxen signed rank match pair test.